Mm.
Okay, so let's start the machines. First, let's access them,
Yeah.
then we'll start.
So in January, can we complete the course?
Yeah, this will be like around 12 to 15 days max it will take for this Kubernetes. So it's
You said
22,
25
so
days.
25 in like total 25 I'm talking about. So 3 4 days already have gone.
Okay, okay. 12 to 15 days, huh?
Yeah. After
In,
that
in
we can start the next. Huh?
in January, we can complete the course then.
Yeah, in January, by the end of the January it will be done.
Mm. Yeah.
Jenkins, Negios, Git, right? We have these three remaining. Other than this,
Terraform.
Terraform is also there. Terraform, I'm not sure about how much duration that will take.
Ah. So this recession won't impact to get a job as a fresher in DevOps.
No, no,
Ah.
because in this as well, they need people who will be working with the package
Low
might
package.
differ a little bit, but
Mm.
job you'll get.
Mm.
But the package will definitely be impacted with this because of this.
Mm.
Good, 3 2 1
Actually,
and
I got one offer from one company.
mm-hmm.
So that is for a digital marketing. So where I'm doing digital marketing now. So same digital marketing. So I got an offer from one company. So they offered me 4.8 LPA.
Mm-hmm.
So I'm a little confused. So whether to join or better to join as a DevOps after 2 or 3 months.
It would be better, according to me, it would be better for this DevOps
Mm.
only because in marketing, this line in long term, the package will be
Mm.
less compared to DevOps. Like if you work for 2 years in DevOps and 2 years here, the package in DevOps will definitely be more.
Yeah, that's what I'm thinking, sir.
You, at the start, you might get low, but
Mm.
after some time, it will
Yeah.
definitely be better than that.
Mm. Yes, sir.
Okay. So yesterday we saw how we can create pods,
Yes.
and we also used this pod.yml to deploy a pod
Mm.
using a file. Just hold on 2 minutes.
Mm.
Okay, then we'll
Yeah.
start.
Okay.
Hello.
Yes, sir.
Let's start then. So in last session we talked about pods. Okay, how we can create pods using command method and then
Fine.
the file method.
Yeah.
Okay, but there was some issues regarding deploying the pods, and that was if we if we are deploying one pod, that can be done via the command, no worries. Okay, but if we are deploying multiple pods, in that case we need to run the command multiple times. So the scaling feature is not available to us. Okay,
Yes.
and another thing is, let's say we deployed multiple pods by running the command, but they will be deployed across the cluster. So by
Mm-hmm.
default, there will be no load balancing between these pods. If they are of same image, in that case, the request can not be divided on these by default. Okay, so we need to configure that, and everything needs to be done manually, and that will be very complex. So
Yes, sir.
instead of deploying them one by one, what we have for this for this auto scaling and then load balancing, we will be using controllers. Okay.
Mm-hmm.
So in controller, we already talked about that cube controller manager.
Yes.
Okay. So mainly what this cube controller manager it is a set of processes which are available, okay, which is monitoring all the pods across the cluster. Okay, like if we have these two nodes, this one is worker one, this one is worker two. So some pods are on worker one, some are on worker two. So this cube controller manager will do the monitoring of all the pods, whether they are up or not, whether they are healthy or not. Okay. So,
Mm-hmm.
so by checking that, what it will do, it can manage a certain number of pods running. Like if we want that at least 20 pods should be in running state. So by doing the monitoring, this cube controller can do that. So what we can do is we can provide the desired value here, what we want, and according to that desired value, it will manage the current number of pods which are running. Okay.
Okay.
So
So it means once after creating a pods, the cube controller will help us to control the pods. Like if I want to turn off some pods or delete some pods like that.
no, that will be done by cube controller automatically. Like it will automatically manage the pods. It will do the monitoring continuously. If we want that a certain number of pods should be running, let's say I want 5 pods to be running at any time.
Mm.
Okay. And I deployed 6 pods of that image. So what cube controller will do is it will remove 1 pod from there because
Okay.
only 5 should be running. So if by some chance, by some error, more pods are there or less pods are there, cube controller will manage those pods and then increase or decrease according to the requirement.
Okay.
Okay.
Got it, sir.
What it is a set of processes which is monitoring all the pods across the cluster. Okay. So for
Yes.
monitoring, multiple controllers are used for different nodes. Okay. So now what we're gonna use is we have three types. First one is replication controller. Controller. Second one is replica set. The third is deployment. First, let's talk about these two: replication controller and replica set. This replication controller was the older version which was used, and this replica set is the latest version.
Mm.
Okay, so we will be using the replica set only, but you should know what replication controller is. So first we'll talk about this one, then we'll move on to the replica set. There is a minor difference between these two. So in this replication controller, we will define the desired value of the pod that we want, and it will automatically manage the load balancing and auto scaling of the pods depending on how many worker nodes we have. Okay. Session controller will define the desired number, or you can say desired value of pods. Also, load balancing and auto scaling of the pods will be handled by replication controller. So I'm calling it RC. Okay.
Yes. Yes.
RC is a replication controller, and replica set will call that RS.
Okay.
So for this replication controller as well, what we'll do is we'll create a definition file. Let's say in that definition file, we told it that the replicas should be 15.
It means 15 pods. A replica in the sense 15 pods.
Yes, 15 pods. So at any
Okay.
time, it will maintain that number. It will keep at least 15 pods running.
Mm.
Like we have three worker nodes. So it will deploy the pods on all the worker nodes across the cluster. Let's say six, one, two, three, four, and five. First of all, it will deploy them, and then it will also do the load balancing on all these pods automatically. Okay. If
Mhm.
something goes wrong in this pod, let's say this pod is not working, it failed. What it will do is
Uh,
remove
Another.
that pod.
Yeah.
It will delete it and deploy another one.
Okay.
It can be on the same machine or it can be on a different machine as well.
Okay.
Okay.
That will be handled by uh, replication controller.
Replication controller. It will continuously check it. Okay.
Okay.
So like let's go here on the machine and create a replication controller definition file. If you remember in last session when we described the pods,
Hmm.
there was a key called label, right?
Uh, Label.
Right, label.
Wait, sir.
So in when we describe the pods, let me just show you here. When we use kubectl describe pods and the name of the pod if we have any pod. Okay, like right now if we do get pods, we don't have any. Kubectl get nodes describe node worker one dot srk.com. See,
Yeah.
right? So on the node, a label is there. On pods, a label will also be defined. So what this RC, this replication controller will do is it will monitor the pods according to the label. Like when we are creating a definition file for the RC, there will tell that on all the pods a label will be assigned, and let's say the label is app and we are using it for web. There's mouse. So this web label will be defined on all the pods.
Yes, sir.
So with the help of this label, this RC will monitor them. Okay, because we will not only have 15 pods across the cluster, right? We can have 15 pods for the web server. We can have 15 pods or more than 15 pods for database as well. We can also deploy for another project as well,
Hmm.
right? So every project or every use case will have a pod for them, and each pod for that use case will have a certain label assigned on them. And
Okay.
this RC will monitor them according to the label. Okay. Like in the
Yes.
last session when we created this pod.yml, here we didn't provide a label. If you want to provide a label, you need to assign it in this metadata part, just under the name part.
Okay.
Okay. So
Yes, sir.
let's create a file, a definition file for RC. So let's name it rc.yml,
Okay.
application controller.yml. Again, four things will be here:
API version
API version,
V1 version 1.
right? That will be v1,
Metadata
metadata, and
name.
spec. At
Ah,
least these are the four main parameters. Inside them, we'll declare each. So the version for this replication controller is v1 only.
yeah.
Okay. Here, what kind of resource we are using? A
Oh,
replication controller. No, we are not deploying pod right now. What we are creating is a replication controller definition file.
okay.
So here we'll write replication
Controller.
controller. Then in the metadata, we can give a name to this particular application controller. Let's say my app. Okay. And in spec, we need to provide the details regarding the pod. Same things that we had in the pod.yml. Okay, but this time they will be declared inside another
Replica.
keyword that will be called template. Replicas also we need to provide. Just here we need to provide how many replicas we want to create. Let's say we want to create 20 replicas. But what will be the definition? What will be the pod configuration? Those will come under the template part. Okay, so
Okay.
first it will be template. After that, everything else will remain same as we had in that
Done.
pod.yml. Like, let me just duplicate it here. Sudo cat pod.yml. Okay, so just leave these two, API version and kind. We don't need to repeat these two, but other than this, metadata, spec, containers, name, these things will be just written as it is inside this file.
Okay.
Okay, so either we can copy it for now at the start, try to write all the files manually. Okay,
Mm.
so you'll get the hang of it. So in
Yes.
metadata,
Name.
I'm providing a name for the pod. Let's
Yeah.
say pod one, or let's say my pod. Then other than name, we also need to define the
Image.
labels.
Okay.
Image will be defined in that containers part. Okay.
Sir, I have one question here.
Hmm.
So I'm totally confused because we are doing here we are not deploying any, we are not creating any pods.
No, we are creating a file for replication controller. The deployment of the pods will be handled by replication controller now. Now we won't deploy them manually. We will just tell that replication controller should deploy and maintain this number of pods.
Okay, okay,
So
okay,
for
okay. So
maintaining
this
that, we need to
uh,
define. Hmm.
it means this replication file. So what we are writing a file to create a replication. So particular this file can handle up to 20 pods.
Right.
Okay,
Okay.
okay, got it, sir. So here we won't include anything related to pods. Here this is only for a replication file.
No, no, the pod definition also we need to define. Like the pod file that we created, we will be defining the same things here because, like, if you don't compare, like, let's talk about that auto scaling. In auto scaling, what we were doing, first we created a launch configuration or a launch template, right?
Mm.
Because
Yeah.
when a new instance was deployed, we were not available at that time.
Mm.
Okay, so we created a template for that. So in case load increases at night, a new instance will be deployed with the same configuration,
Okay.
right? So same thing we will be defining here, that 20 replicas should be managed,
Mm.
and what type of image or what container the pod will have, that image will define under this template part.
Okay.
First, metadata, we are naming the pod, what the, like if we are deploying 20 pods, the name of those pods will start with this. Okay.
Mm.
Then labels, we always need to define here because this replication controller is monitoring or will be monitoring the resources with the label only that we will use here. Okay. So in deploying a single pod, we didn't use a label because we didn't need it that at that time. But when we are creating replication controller, we need to provide labels here so that RC, the replication controller, can monitor the pods. Just let's create it, then you understand. Like in labels, I'm providing a label app and the name is web. Then just under metadata, I'm creating another key spec, and in that containers here we will provide the name for the container. We can put it anything, and image, which image should be used? Let's say Nginx. Okay.
Mhm.
So now via this file, the replication controller will be created, which will be managing 20 replicas, 20 pods, and the configuration of the pod will be fetched from this. Okay.
Okay,
So if
so
there
in
are,
this file,
hmm, yes,
so in this file, we given all the instruction that we have to create a replication. That replication should handle 20 replicas. It means 20 pods, and also create a pods also 20 pods also, which
correct,
like which is the image contain nginx. So this is what we are telling in this file.
right. So it will manage everything.
Controller. Okay.
Like let's save it.
So, so this
Hmm.
replication controller, what is the main function of this replication controller is, if anything happen to any parts, if the pod gets turned off, or if the pod get destroy, then
Hmm.
automatically the another pod will create
Correct.
for
For high
only this purpose.
availability and load balancing, we are using it. Not for the auto scaling part, not for only the auto scaling part, for also for the load balancing part, we are using it.
Okay, but we mentioned that the replica is maximum 20. Within 20 only we can manage by using this replication controller.
Yes. By default, like what we have configured here, 20, it will only manage 20. If you want to change it later on, you can change it.
Sir, now my question is, now 20 pods will create after running this file.
Yes. Hmm.
Okay, what is the name of 20 files? My pod.
20, 20 files, no, 20 pods will be created. Let me just run it just a sec. Like
Okay,
if we
sir. Okay.
do kubectl get pods, right now we don't have any pods here. Okay. If we do kubectl get replication controller, right now we don't have that as well. Okay. So you can either write this full replication controller, or you can also write kubectl get rc.
Hmm.
So for creating pods by using this file rc.yml, the command will be same kubectl create -f file name. For pod.yml, we also use the same command. By using that pod.yml, it only deployed a single pod. But if we do it right now, and if you check it again, get rc, what's the desired value?
20.
20, current 20, but out of those, at that time 0 were ready. Now we have 2, 5. Let's put this command under watch. 11, 14, 17, 18, and 19 and 20. So now what this rc.yml did, it deployed 20 pods here.
Hmm.
Okay.
Okay. Okay.
If you do kubectl get pods, see,
Okay.
20 pods are here, and every pod is in running state.
Yes, sir.
So what this desired means, the value that we
Given.
want. What this current means, the value that is currently available. Okay.
Hmm.
So if I copy the name of this pod and destroy it, kubectl delete pod paste. See, it automatically deployed another one. If you see
Okay.
the age for the rest of them is 97 seconds. The age for this one is 7 seconds.
7 seconds. Okay.
Okay. If I delete another one, It will again check what's the current value. The current value will change to 19, and it will try to manage that current value and change it to the desired value. So it
Okay.
will again get us 20 pods. So let's delete one more. 19s were ready at that time, and again 20 are ready.
Yes, sir.
The age for this one is only 14 seconds.
Yeah.
Okay.
Yes, sir.
With this application controller file, resource file, we can manage multiple pods at the same time. We can manage the high availability of the pods and the auto scaling and load balancing of the pods. Okay.
Okay.
So you understood this desired current and ready state? Any doubt
Yes.
in this? What's the
No.
desired?
Desired means what we given, no? So we have to create 20 pods. So that is desired. And current means currently total number of pods available. And ready means
Mhm.
total number of active pods. It means now it starts from 0 to 20. Uh,
Right.
that 20.
Okay. You can just
Uh,
like mm, in a room, if you have an AC and if you set it to, let's say, 20 degree, so the desired state that you want is 20 degree, and the room temperature, it might be, let's say for an example, it's 30 degree. So that's the current state. So what
yeah.
the AC will try to do is it will decrease the temperature to and make it
Mm,
to 20 degree, and if it is less than 20, then it will increase that. Okay.
okay. Mm,
That same thing is happening here. The RC is managing everything, replication controller is managing everything, and it will always try to keep the desired number of
mm,
pods running here.
mm, yeah.
Let's say if we want to increase the pod or change the replica number, you can just go to the rc.yml. Let's say instead of 20, I want to create 50 pods.
In
Okay.
working scenario, maybe it's in
Hmm?
thousands.
No, it depends. It depends on your scenarios. Like if you are not working on that much of a big project, in that case, it will not be in thousand, in hundreds only. It will be.
Hmm.
In some cases, it might be lower than 100. So, yeah, what would yeah. So here we change the value
So
to 50.
50. Yeah.
So we need to run the command. Like if we get RC, right now it is only showing 20. But if we do kubectl replace -f and the file name. Now the value has been changed. If you do kubectl get pods and put it under watch, see, they are being created and the container is also starting on them.
Yeah.
At any moment, we will have 50 containers, which are 50 pods, which are running in the cluster.
Mm,
Okay.
yes.
So this is the first method by which we can increase the number of replicas. We can directly go to the file, change the value, and use this replace command. Second is we can directly change it from the command line. So what we want to do is we want to scale RC, and the number of replicas is, let's say, 100. And what's the name of our RC? Replication controller name is my app.
Yeah.
It has been scaled.
Yes, sir. Uh, Now this ready will increase, right?
Yes. Is it increasing? Just a sec. Pods. Let's see. Ready 0. Kubectl describe RC my app. 50 are running, 50 are waiting. Kubectl describe or get nodes -o. Okay, they're not ready. Why? Machines are up. The load might have been over the limit for them. Let's delete it first. Kubectl rc.yaml. Ctl get ports. Let's wait for them to terminate first. SSH on IP of this is the machines are not accessible.
Why? What's the reason, sir?
Hmm?
What's the reason?
Your voice is very low. The thing
What is the reason why it's not accessible?
we deployed too many pods on them. They only have 1 GB of RAM, that one CPU.
Yeah.
just reboot these three. Ubuntu and if you want to declare more, you can use the t2.small version, the instance type. But under free tier, it's not there. It will incur some charges, not that much. Have you done that waive off request
Huh?
for your account? Have you waived off your bill? Contacted AWS for that?
No, sir. I created another account, na.
Okay. And that no bill is there?
Novella.
No bill is there.
No bill. No, sir. No, sir. There is no bill.
Why is it taking this much time to stop here? Now let's start it again. Paste. Worker 1, 2, and 3. Get nodes. Now they're ready in rc.yml. Let's keep it to 10 only. kubectl create -y rc.yml. Not y-f. Okay,
Mm.
it is
Yes, sir.
creating 10 pods. The second way to change the number of replicas, first way we already saw, we can change it in the file and then use the replace command. kubectl replace rc and then kubectl replace and then -f rc file. And
Yeah.
the second method is to change it by the command directly. kubectl scale rc and -replicas. Let's change that to 20. My app. Okay.
Mm-hmm.
kubectl get rc. So 20 is the desired value and ready also 20. Okay.
Yes, sir.
So now rc will monitor all the pods whose label is app and web. That's what we defined in rc.yml. Okay. If we do
Yes, sir.
kubectl describe rc my app, see which label it is checking. Labels app should be equal to web. So if we have 50 pods running with different labels, it will at least keep 20 pods with the label web. Not more than that, not less than that.
Okay.
So by default here in replication controller, it will take the label by default, which is whichever label we have defined there, it will take that label. Okay. The replica set, the next thing that we have, it is also doing the same thing. It is also managing the pods. It is also doing the auto scaling of the pods, load balancing of the pod. The only thing that's different between replication controller and replication set is this label option, or you can this selector option, by which you are monitoring the pods. Here it takes the label by default. In replica set you can define which label to monitor.
Mm.
That's the main difference. Like if we across the cluster, this one is our cluster, and here we have multiple pods running. 2, 3, 4. Okay. 3 machines are there. 3 worker nodes. On those 3 worker nodes, different configuration pod are running. with different images. Just for a scenario, let's say three types of pods are running. So on all these pods, we'll define different labels here. Let's say three RC we have created. First RC in which we have given the replica number as 50. Okay, the red
Yes,
one,
sir.
and there I have defined a label app, or let's say color red. Another replica controller is there with replica set to 20, and there I have defined the label as orange, and another RC is running. The label on that one is purple. Okay, so it will automatically manage all the pods which are running. This RC will manage 50 pods, this RC will manage 20 pods, and this RC will manage 15 pods. And by default, it takes whatever label is there in case of RC. But when we go to the next part, that is replica set, or you can say RS. So here we can have multiple labels. First of all, let's say color is purple and app is web. Another one, color is orange and app is DB. Just hold on a minute. Arshu, another one. So right now, if we have this kind of labels here, okay, in replica set, you can define that which label you want to monitor. Okay, so it will be easier to manage. Like if we want to check that it should be like this app in web and DB. So what this replica set will do is it will monitor the pods whose label is either web or
DB.
DB. If you go here, let's just go to the replication controller. Kubernetes. Replication controller we have already seen. What replication controller is doing, it ensures that a specified number of pod replicas are running at any one time. So same thing, v1 API version, kind metadata in spec, replicas. Here we have the option, we can define this selector now, but if we don't define it, it will take the default label whichever is there. But in case of replica set, this section is mandatory. Okay, in RC it's optional, but in case of replica set, this selector option needs to be there.
Okay.
Like if we go here and replica set. Again, purpose is to maintain a stable set of replica pods running at any given time. So the work of both the things is same. Replica set is the newer version and replication controller is the older version. That's it.
Okay. Is there any difference between both?
Yeah, the difference is this only, the selector option.
Okay.
Application controller versus replica set. The only difference between replica set and replication controller is the
Selector.
selector types.
Okay.
Okay.
So we are going to use replica set only.
Yes, we'll be using replica set only. Let's see if they have defined it here. This they haven't defined it. So the only difference is this the selector option that we are defining it here. In case of replication controller, it was taken by default, and here you can tell which particular label you want to monitor, which
Okay.
selector you want to use. Everything else will remain as it is. Like if we go here and we want to deploy pods using replica set. So the file we can use same rc.yml, just we'll change the name there. Faster. Sudo and kubectl get rc, that's there, ls. So I'm just copying that file rc.yml to rs.yml. Okay.
Mm.
So in rs.yml, first of all, the API version for replica set is different. For
Okay.
replica set, the API version is apps/v1. Okay.
Okay.
Other than that, the kind will also be different. In kind, what we need to write? Replica set with rn as capital.
Mm.
In metadata, we can change the name. Let's name it rep set. We want to maintain 15 replicas. Let's use the name of the pod to new, and we are changing the labels on the pods that will be defined here. Let's change it to website. Okay. One more thing you need to remember is that if we already have some pods running in the cluster,
Okay.
okay, let's say in replica set we have defined the label as app should be web, and the number of replicas we have defined is 15. So what will happen if there are already 10 pods which are running with this label?
Mm.
So what replica set will do, or what replication controller will do, it will only deploy 5 more pods
Yeah.
to make the number 15.
Mm.
If we already have 25 pods running with this label, and in rs or rc we have defined replicas as 15, it will remove those extra 10 pods. Okay.
Okay. Mm.
So it will check the particular label, particular selector will be used to monitor the resource.
Mm-hmm.
Let's see, Apache HTTP. But in replica set, we need to define the selector. So a new option will be added, selector, and here we will match the labels, match labels, and the labels that needs to be matched is app, website. Okay, so the label that we are matching and the label on the pod must be same.
Okay.
Save it and kubectl create -f rs.yml. Now before running this, if we do kubectl get replica set or rs, right now we don't have any. Let's create it. So desired 15, current 15, and it will also change the ready 7, 11, 13, and 15. Okay, so if we see here kubectl get pods,
Mm-hmm.
see 15 pods have been started by the replica set and the 20 pods are running by the replication controller. If we remove any of them, it will automatically manage kubectl delete pods and paste. So a new pod has been started just 4 seconds ago.
4 seconds. Yes, sir.
Okay,
Okay.
so that's the main difference between these two, the replication controller and replica set.
Set. Yes, sir. Okay.
So now let's remove them. Just hold on a sec. So kubectl get rc get rs. Kubectl delete -f rs.yml rc.yml. Okay,
Yes, sir.
now the next option, like we will be using this replica set only. Okay, the rc was the previous version, so just
Mm-hmm.
for information we saw it here, how it is working and what's the difference, only that part. Okay, later on we'll be using rs only, replica set only.
Okay.
Now let's say we have 15 pods which are running by the replica set. Okay, and if you want to update them, let's say the application that is running there, you have you want to update the application.
Mm-hmm.
Okay, so if you update them all at the same time, what you need to do here in replica set is you need to remove them and update them manually. In replica set or in replication controller, we don't have the option for rolling update, or if you want to go back to the previous version, which is called rollback. So if you want to update your environment, update your pods, or if you want to roll back the environment, we don't have the option that in RC or RS.
Okay.
For that, we will be using the deployment. So in deployment also, the RS will be created.
Mm.
Okay.
Okay.
So here also a replication set will be created, but we will have the option for the updating and rollback. Okay.
Yes, sir.
In Ansible, if you remember, we had that two values, fork and serial.
Okay.
What those two values were doing?
Sorry, sir.
Why were we using those two values in Ansible? Fork and serial.
Uh,
Forgot.
I'm not getting, sir. Or consider where we used.
In uh, before roles that include an import part, there we had in that
Yeah.
session we had this fork and serial.
Okay.
We just do one thing. Just check the work what these two values are doing, fork and serial. Okay,
Ah.
in Ansible.
Okay.
Okay, so tomorrow what we'll do is how we can create a deployment. Okay,
Mm.
so that is not a very big topic. It's similar to this RS and RC, so it will be completed
Mm.
quickly. After that, we'll start the next one, which is services in Kubernetes.
Sir,
Till now, what? Yeah,
uh, yeah, tell me, sir. You were telling something.
till now, what we did is we just deployed the pods here, right? But
Mm.
if we want to expose them to the outside world,
Mm.
what we need to do is we need to use the pods. Okay, so tomorrow we'll see how we can expose our pods to outside world.
Okay.
So you need to do only two things today. First is do the practice of replication control and replication set.
Mm.
And the next thing, fork and serial. You need to check what these two variables are used for.
Mm.
Okay,
Okay.
in Ansible.
Yeah.
So these two things you need to do by tomorrow. And tomorrow we'll start the next topic then and complete this deployment.
Okay.
Save it. Fish controllers, RC and RS. And are you doing the practice of the previous topics?
Kubernetes. You're talking about Kubernetes, sir?
Yeah, Kubernetes and as also the previous
Yeah,
technologies
Kubernetes
like
I'm doing. Kubernetes already completed yesterday topic. Docker was done almost, but writing a file is remaining. By this weekend, I'll complete Docker, and Kubernetes, whatever you teach me till Sunday, I'll complete all the topics in Sunday for sure. And Ansible is remaining, and
Mm.
AWS I completed 1 month back itself, but again I have to go through the topics. AWS I felt it's not tough, but only thing is we have to remember the uh, you know topic and for what purpose we are going to use the service and all these things.
Right.
But
And
this Ansible is there now. It's very difficult. I felt it's not very difficult. That variables and nodes. Sorry,
Mhm.
some topics are there now. We have to remember all these things.
It's like don't leave them altogether. Just keep on doing some things from those as well. Because if you just leave them, it will be tough later on to get back on them again. Just give
Yes.
them few minutes only, but on every weekend try to give some time to that. Okay.
Yes, sir.
And
Mm.
if you want to do a practical for this AWS, you can use this one. So in this diagram, what we are doing here is that in two different regions, Mumbai and Ohio,
Mm.
we are configuring auto scaling.
Okay.
Okay. So in auto scaling group, the minimum and maximum is 1 and 3.
Mm.
Okay. We will be using a launch template for this. And in the launch template, the website will be fetched from the S3 bucket.
Okay.
Okay. So the website code is available on the S3 in a zip file. So that
Mm.
file should be fetched on the instance, unzip it on the instance, and then
It will run.
create in that directory where www.html. Okay.
Mm.
So the script is also here, which you need to add it in the template while creating the template file. An
Mm-hmm.
IAM role needs to be attached on the EC2 so that it can go to S3 and fetch the detail from there.
Yeah, got it.
Okay, so the steps with the steps it is available here.
Okay.
Okay, so you can try practicing it.
Sure, sir.
And I did a mistake here and terminated all the instances.
Oh my God.
So again,
We
I'll
have
try
to
to do
install.
the installation. Otherwise, we'll do it tomorrow evening.
Mm. It takes on 30 minutes.
Hmm. Now it will not take 30 minutes because some commands are already we have here, and that for the CNI the commands are already there.
Mm.
So we just need to copy the commands from that file.
Yeah.
This Kubernetes. See here. So we'll just copy them, and only limited commands we need to run. And
Yes.
tomorrow what we'll do is we'll just create a history file for the rest of the process as well. It
Mm.
will be easier.
Yeah.
Okay, and make sure to check that fork and serial value. Okay,
Yeah. Mm.
and do the practical of these
Sure,
RC and
sir.
RS.
Yeah. Will do.
Okay, then tomorrow evening we'll do the session.
Okay, sir. That's it for today.
That's it for today.